Okay, first steps up, you want to make sure that there is no residual dust or debris on any of the mixing apparatus. So in this case, I'm using a funnel, 1 liter beaker. And here in the lab, we have reverse osmosis water, which makes it pretty convenient to make sure you don't have any impurities. And by impurities, we're really talking about, like I mentioned before, dust, debris, but also any contaminants that sometimes can be in water supplies. This process of making STS, the silver is very reactive, and it has a tendency, if there's over-mineralization in the water or dust and debris, has a tendency to precipitate out, and what you'll end up seeing is black in your solution. If your solution turns black, you want to get rid of it. And by black, I mean, you can kind of see this is an old bottle that I'm no longer using, but I'm just keeping around for examples. You can see that the outside is completely stained black. And on the inside, maybe difficult to see here, but on the inside there is black, some small black chunks that are present in the STS, in the silver nitrate. You don't want that. It causes all kinds of problems. Okay, so I'm going to use little plastic measuring boats. And as I mentioned before, you're mixing up proportions of 5 to 1. 5 parts sodium thiosulphate and 1 part silver nitrate. So let's begin with the sodium thiosulphate first. Put the boat on the scale, zero it. And in this case, I'm going to use a little scoop. This sodium thiosulphate is crystalline, but a little bit sticky. So I'm going to measure up 5 grams. It's 3.5, 4.2. All right, that's 5 grams. Now I'm going to add this using the funnel. I'm going to add this to the 1 liter beaker. Goes in pretty easy, but a lot of times you're going to get a little bit sticking on the top. So with 5 grams of sodium thiosulphate, I'm now going to mix that with 1 liter of water. Use the water to wash around the funnel. Once that's cleaned off, set it aside. All right, we got 1 liter. As you can see, maybe you can't see, but those crystals are basically in, the bottom of the beaker. And what we need to do is just gently agitate the beaker until those crystals have fully dissolved. Would it work better with hot water? Of course. Problem with hot water is that it's, in most cases, going through a heating element inside of either a hot water heater or a tankless system. And in some cases, you're picking up trace bits of metal in that. And in a lot of cases, that little bit of contamination ends up precipitating your silver out in the final solution. So best to use cold water, even though it takes a little bit of extra time. And what I'm going to do here is get prepared as this is mixing and clean out our 2 liter pitcher, because what we're going to do is we're going to combine the 1 liter of sodium thiosulphate with 1 liter of water that's been mixed with our silver nitrate. Getting pretty close. Now one little, as usually happens, there's one little straggler down in the bottom. And you can see it as it spins around, it's dissolving ever so slowly. Okay, I'm gonna call that good. Empty our pitcher. I'm gonna pour our 1 liter in there. Clean the beaker. Now we're ready for the silver. So again, 5-to-1 sodium thiosulfate to silver nitrate. So I used 5 grams of sodium, and now I'm going to use 1 gram of silver. Silver I just pour in here ever so gently so as to avoid introducing external contamination. Just makes it last a little bit longer. All right, I over fucking did it. That happens. 1.3. There we go. 1 gram into the beaker. Now this one, this one dissolves much more rapidly. Then you're going to see a little bit of a blue, hazy tint in that. Now, if it turns black, you know you got a problem. Just dump it out, start over. If it continues to be black at each stage, I'd recommend switching to distilled water so as to reduce any potential contaminants. All right, we got 1 liter. You can see it's still pretty hazy, which is great. Spin it around a little bit. Now I'm literally going to just dump that in. Now, this is great. This is relatively clear. You can see a little bit of a haze on this, but it's free of black particulates, which is the most important part. So now I'm going to, in preparation for being able to just put this directly into a sprayer, the next step in the process is to dilute 3-to-1 regular water to your stock solution. So this is 2 liters of stock solution, so we're going to need 6 liters of water to add to it. So I'm going to start off by pouring this into the 8-liter container. All right, STS stock solution introduced. Now I literally just fill up this 2-liter pitcher 3 times to dilute, and your stock solution is ready to go. It's important to count as you do this. That's 1 pitcher. Oh. Absolutely critical to laugh like the Count from Sesame Street, otherwise you will lose count. Basic scientific knowledge, everybody knows that. 2. Oh. And 3. You don't have to laugh on the 3rd one, because the job is complete. All right, so now we have 8 liters of STS. Mix it up, stays clear, that's great. This is a good batch. Turn off my scale. We'll get ready to apply this to plant. Okay, so I'm about to start the spray process. Give you a little insight. So today will be the 3rd spray on branches that are marked. and the second spray on the other branches. These are the F1s in Project TAC, where we're doing some work to identify the genes responsible for total cannabinoid concentration and create some lines that maximize that potential. So as you can see on these plants, that discoloration is from the STS spray. So I got lazy and I sprayed with the lights on, which with certain varieties is really bad. With other varieties, they can handle it. This one is kind of intermediate. You can see on this plant, the damage is a lot more minimal. On other individuals, that's causing leaf death and complete chlorosis. So what I'm going to do today is turn the lights off, and I'm going to use my pump sprayer. When we're doing large production rooms, reversing whole greenhouses of pollen donors, use a standard atomizer, and the goal is to get the STS into the stomata of these leaves. So you want to make sure that the plant has already been watered for the day, and you want to do everything that you can to make the stomata be open and receptive. So what happens is that silver solution is introduced to the stomata and then transports basically into the plant and suppresses ethylene. The plant natively is making ethylene right now, as these plants have been in flower for 10 days. So normally they would be cranking out ethylene and getting ready to produce a bunch of female flowers. But because these leaves have been drenched in silver solution, they are not producing ethylene. They're going to actually produce male pollen. Male is in quotations because these are obviously female plants. So we're producing female pollen, but it makes seeds and results in plants that are 100% female. So that's what it looks like. Today I'm going to turn the lights off and not be lazy, and I'm going to saturate these plants with my little pump sprayer until they're basically dripping, and I'll let them sit likely for about an hour, just so that they can dry off a little bit, and we'll hopefully end up with a little bit less phytotoxicity here. But that's the process. Just a real quick note on best practices when you are spraying plants in a tent. So like these are single plant reversals rather than a whole room. I tend to start from the top of the plant and work my way down on the spray so that you're basically getting the maximum amount of STS solution on the plant as it drips down. I also will cover the tops with my hand just to contain that spray even more. That's why it's important to wear gloves. But that really maximizes the effectiveness of the STS, captures it in that leaf canopy. And obviously you can't get all of it, but you want to get as much as you can. Okay, so 41 plants sprayed. Went through right at 8 liters of stock solution. So in my mind, that's one batch. When we're making a larger batch to spray a whole room of plants using the atomizer, I will often make up 8 liters of concentrated solution, which will then make 32 liters of actual application. So next time I'll probably have to make a little bit more than 8 liters just because the plants are growing. This particular variety is stretching real good in these first 2 weeks of flower, which happens with certain varieties. That is the final application for the branches that have been tagged. but we had kind of made an executive decision to spray the entire plants since we are flowering copies just next door here starting tonight. So these are going to be the pollen donors for a back cross. I'll give you some information on why we're doing a back cross in this situation. We very, very rarely, if ever, do it. This is the first time in a structured breeding program that we have. Some very specific rationale for it. So like I said, these plants are going to rest for an hour, and then I'll come plug the lights back in, and they will continue their reversal process.